The Wikkelhouse is a completely reusable modular home made almost entirely of recycled cardboard, making it 3 times more eco-friendly than traditional housing, and giving it a life expectancy of up to 100 years. Intelligent and Sustainable Housing Solutions, Part 1 of 3. Continue watching to find out more.
Dobry dzień means hello in Belarusian. I'm Sofia. The people of Belarus, thank you for choosing to embrace the sustainable vegan lifestyle. Welcome to our program, Intelligent and Sustainable Housing Solutions, Part 1 of 3. Conventional houses are typically constructed of materials such as wood, stone, brick, and concrete. However, as new housing concepts emerge, housing designs focus resources and technologies with less carbon footprints and environmentally friendly. One of the world's most ingenious, eco-friendly dwellings has been designed by the Dutch company Wikkelhouse, whose innovative home, known as Wikkelhouse, which literally means cardboard house in Dutch, was created by a team from the Fiction Factory in Amsterdam. The Wikkelhouse is a completely reusable modular home made almost entirely of recycled cardboard, making it 3 times more eco-friendly than traditional housing and giving it a life expectancy of up to 100 years. The Wikkelhouse consists of 24 layers of high-quality cardboard that are wound around a rotating house-shaped mold. The layers are then bonded or wrapped with eco-friendly superglue to promote durability and optimal insulation. To make the house waterproof, it is finished with a protective film and a shell of wooden slats. With its 4.6 meter long, 1.2 meter wide and 3.5 meter high segments, the house can be added to and extended as needed. The Wikkelhouse is also 100% recyclable, as each segment may be deconstructed and reused. Regarding the Wikkelhouse co-director of Fiction Factory, Up Schilling said, "When I saw the beauty and aesthetic of the house and the machine used to build it, I thought, wow, this has potential. It's green and it's beautiful." Indeed, the Wikkelhouse seems to have all the design features needed to revolutionize the field of eco-friendly modular housing and is available for construction in the Netherlands, Belgium, Luxembourg, France, Germany, the UK, and Denmark. In another example of environmentally friendly housing, the Los Angeles-based company kitHAUS offers a range of prefab houses made with its patented lightweight construction system. kitHAUS houses consist of many green components to maximize energy efficiency and use of space. The structures are built using the aluminum modular housing system invented by architectural engineer Tim Schahatgar. Although All kitHAUS units are constructed in the company's factory. The houses can be uniquely designed to accommodate any client's needs. The construction team develops a site-specific solution for each project and provides assistance from the initial work site and foundation building for final delivery and installation. The designer and co-founder of kitHAUS, Mr. Tom Santonato, said, "One of our focuses is to make our products as environmentally sustainable as possible. Our units include light-emitting diode LED fixtures and the most efficient kitchen and bath fixtures." An Italian architect, Beatrice Bonzanigo of the IB studio, unveiled her patented design named Casa Ojalá, a circular house prototype that is transportable, adaptable, and off-grid. The circular 27 square meter and 6 meter high micro house has a radial steel structure coated in a wood consisting of a 6 meter upper deck and a terrace floor with 8 meters of diameter. Casa Ojalá is equipped with a rainwater collection system, photovoltaic panels, and a small septic tank. Each unit has 2 bedrooms, one with a double bed and one with a single bed, a terrace, a bathroom, a living room, and a kitchenette. Going green and adopting sustainable houses in our lifestyle is good for the environment and can help to ensure the longevity of our precious planet. Using energy-efficient, renewable, and recycled materials to build a house lessens individuals' environmental footprint.
Yet another remarkable eco-friendly house is the blooming bamboo home.
A low-cost structure made mainly from natural resources and produced in Âu Lạc or Vietnam. The house features a range of sustainable practices and elements. The entire home is constructed from bamboo, a plentiful, fast-growing grass that is found locally. In order to minimize the risk of destruction in severe weather conditions, Hanoi-based H&P Architects has developed this low-cost green building system to withstand the annual typhoons and floods that damage the country's physical assets. Elevated on stilts, the blooming bamboo house is equipped with wooden ladders that lead to small decks around its perimeter. Interior living and sleeping areas occupy the main floor, and ladders lead up to attic spaces that can be used for study or prayer. The area below can be used for growing plants. If flooding occurs, water is allowed to pass through the structure, keeping its residents safe. The prototype house will eventually be sold to low-income Âu Lạc or Vietnamese citizens. Now we'll take a look at the concept of building eco-homes from shipping containers, which serve as strong, durable, and mobile building blocks for creating amazing structures of all kinds, such as micro-houses, office spaces, and cabins. Shipping containers can be used to promote the concept of recycling, and the ideal location can be easily selected since containers are easy to move around. Here is the first example, an off-grid oceanfront cabin on a gorgeous beach in Portugal, north of Lisbon, that was built from 3 used 20-foot, 6.1-meter shipping containers. For its sustainability, rainwater is collected from the roof of a small shed and stored in an underground water cistern. From there, a 230-watt solar panel installed on the roof, which pumps the water into a 1,000-liter container on top of the container shed, thus providing water for the kitchen and bathroom sinks, toilet and shower via gravity. In the next example, Brazilian architect Marilia Pellegrini has created Casa Container, a nicely designed eco-house inside of 2 reused shipping containers located in the city of São Paulo. In 2019, Casacor Miami exhibition held in Florida, USA, the 12-meter-long container house was exhibited as an example of the union of sustainability and contemporary design. The roof is designed to be compatible with solar panels and outfitted with rainwater harvesting systems, which can feed the garden. A lovely patio can also be added to enjoy the outdoors. In our final example, we'll travel to the Middle East to look at the region's intelligent and eco-friendly houses. A group of students from the German University of Technology, GUtech in Oman, brilliantly tackled the challenge of sustainable urban development in an eco-house research project. A unique radical eco-house, which built inside the university campus in Halban, provides comfortable indoor cooling by minimizing heat during hot and humid weather. This sustainable eco-dwelling was developed to incorporate the engineering concepts of solar power, optimal orientation, and natural ventilation. The cylindrical building has large openings facing the north and small shaded windows to the south to provide sufficient daylight and natural ventilation during the winter season. The GUtech team won the first prize for Oman Eco-Friendly House Competition organized by the Research Council of Oman. Advisor to the Eco-House project, Dr. Nicolaus Knebel explains, "We use recycled or recyclable materials like mud brick, adding, we are very proud of them, the students, and their achievements. We offer our sincere congratulations to all the wonderful people who have come up with these awesome, innovative designs and made their knowledge available to all who wish to adopt a sustainable lifestyle." Welcome to our program, Intelligent and Sustainable Housing Solutions, Part 2 of 3. The construction of conventional houses consumes a vast quantity of raw materials, thus creating a huge environmental footprint. To help resolve this issue, new trends in small sustainable housing have emerged. The Eco-Capsule is a smart, self-sustainable micro-house that uses solar and wind energy for power. The energy-efficient egg-shaped dome, designed by a Slovakian firm, Nice and Wise, which allows its inhabitants to live off-grid and enjoy the scenic beauty of nature. The exceptionally compact, low-energy, mobile dwelling is cleverly packed into an egg-shaped form that can be placed almost everywhere. Made of steel and fiberglass, the Eco-Capsule comes with a 750-watt wind turbine and 880 watts of solar power connected to a 10-kilowatt battery. Water is collected from the roof and then run through a reverse osmosis filter. The little home measures only 15.32 feet, 4.67 meters in length, 7.22 feet, 2.2 meters in width, and 14.76 feet, 4.5 meters in height. This compact size enables the Eco-Capsule to be easily transported to any location, making it an enjoyable home for free-spirited explorers who love moving around. Eco-Capsule can comfortably host 2 adults and features a built-in kitchenette with running water. The structure also contains a dry separating toilet, a hot shower, a folding bed, and plenty of storage space for sporting goods or other types of equipment. And architect Sona Polova, the founder and director of EcoCapsule, stated that you can live almost anywhere. If you live in Australia and have a lot of sun but not so much wind, it will be sufficient with just the sun. While, on the other hand, somewhere like the Netherlands, there is lots of wind and less sun. She further explains, mostly, we want to get you out to feel connected with the beauty around you. EcoCapsule can also be used as a cottage, a micro-hotel, a travel trailer, a mobile office, or a research station. In a second example, a group of students constructed the waste house at the University of Brighton, UK, from a variety of waste materials obtained from domestic and construction sites. The frame and floors of waste house are made of recycled wood, and 10 tons of chalk waste from another construction site were collected, pounded remnant earth style to form a wall. This innovative, low-energy home was constructed by approximately 360 students and volunteers, some as young as 15 years old. The construction started in May 2013 and was completed in April 2014. The inner walls of this house are filled with blocks of insulation made from throwaway items such as 20,000 used toothbrushes, thousands of floppy disks, DVD cases, and tons of denim waste. Discarded vinyl signs were reused as vapor barriers all around the structure, while 2,000 old carpet tiles were used as exterior cladding. A series of sensors in the external walls of waste house will monitor the home's insulation properties at key points and measure just how efficiently the different materials perform. The Brighton Waste House was designed by senior lecturer and architect Duncan Baker-Brown. In September 2015, Waste House was nominated for the Royal Institute of British Architects Stephen Lawrence Prize. We sincerely wish that the brilliant example of the Waste House can help lay the foundation for a new wave of sustainable architecture and housing. Kudos to architect Duncan Baker-Brown and the students and volunteers who helped to build Waste House for providing a creative example of reusing discarded materials. We'll now travel to Estonia to look at another inspiring eco-friendly housing design. Coda is a sustainable and portable two-story mini-house with built-in IT that enables the structure to learn from and adjust to its surroundings. The house was developed by Kodasema Oy, an architectural and engineering company based in Estonia. Coda is a home that has all the necessities for living while addressing global concerns about growing population rates and the related demands for affordable living units. The Coda home occupies a 26.4 square meter floor space containing a living room, a kitchen, and a bath shower facility, along with a bedroom and laundry room upstairs. Solar panels are mounted on the roof to generate power, and inside are smart home devices including alarms, adjustable LED lights, and climate control equipment. Large windows and quadruple glazing maximize heat and light, and many components can be customized to best fit any given purpose. According to Mr. Ullermark, a co-founder and system architect of Kodasema, 31 Koda modules have been built and installed in several European locations for different uses. He further explains, there is a great advantage in using Koda modules for public buildings. The modules can be easily relocated and repurposed once they are no longer needed at the original location. Let's next explore an exciting, self-sufficient, eco-friendly house called Earthship, whose designer is renowned architect Michael Reynolds. Essentially, Earthship homes are built with recycled materials such as rubber tires, glass bottles, aluminum cans, and other repurposed waste. Mr. Reynolds took cans, wired them together into bricks, which were then cemented together and plastered over, rather than using energy-consuming recycling methods to break down the cans as a whole. Mr. Reynolds calls this method Earthship biotexture. The old tires were made into a powerful thermal mass by filling them with soil, hence making the room created from these materials cool in summer and warm in winter. Solar panels were later introduced to Earthship's designs along with geothermal cooling. Well organized as enabling sustainable lifestyles, Earthship biotexture is constructed based on the following key elements: building with natural and recycled materials, installation of renewable energy systems, thermal, solar heating and cooling, rainwater harvesting and filtration, self-contained sewage treatment, and plant food production within the structure itself. We'll now present another sustainable house featured on today's show. Sukup Safe Tea Homes are a line of interesting dwellings designed specifically for disaster-prone areas where earthquakes, hurricanes, high winds, and storms are frequent or severe. The Sukup Manufacturing Company and GUtech Global, an Iowa, USA-based philanthropic organization, combined forces to provide this innovative way to bring disaster relief and comfort to families around the world. The Sukup Safe Tea Home is a highly modified grain bin that is resistant to earthquakes, termites, and moisture. Grain bin houses or silo homes provide refugee housing for families who need a safe place to live. While Sukup deals with manufacturing the homes, GUtech makes sure they are put to good use in remote villages. Sukup Safe Tea Homes collect rainwater from their roofing systems while deflecting heat and providing ventilation to keep the interior cool. The all-steel tea home construction is fireproof and termite-proof and should last for 75 years. The overall structure stands 13.5 feet 4 meters from floor to roof peak, and the side walls are 8 feet 2.4 meters tall. With their round shape, the units can withstand high winds and earthquakes. Any unskilled person can assemble the tea home as it's extremely easy to set up. Apart from security and comfort from the effects of weather provided to disaster-stricken inhabitants, tea homes can be purchased at a highly affordable price. In October 2016, the Sukup tea homes built in Haiti, which protected the country's residents from Hurricane Matthew, one of the most powerful Atlantic hurricanes in recent history. The executive director of GUtech Global, Mr. Paul Van Gorkom, said, "When Hurricane Matthew hit, we are very happy to say that all of our safety homes, which is nearly 200 in Haiti now, are still standing. We are grateful to the talented and considerate architects who are greening the housing solutions. May God bless you." Welcome, eco-friendly viewers, to today's show, Intelligent and Sustainable Housing Solutions, Part 3 of 3. As we progress through the Golden Age, we are seeing more and more advances in the area of green building technology. For example, the traditional machinery used for construction is now being replaced by 3D printing or additive manufacturing, the process of making three-dimensional objects from a computer-assisted design, CAD, or digital 3D model. One of the first awe-inspiring examples of this work comes from Mireko, an Australian biotechnology company dedicated to new designs of green, prefabricated houses that are highly sustainable and efficient. Carbon acid storage technology, CAST, is among the range of innovative techniques developed by Mireko. The Perth-based company's houses are made mainly from hemp, an eco-friendly building material. Mireko is involved in a collaborative venture with architectural firm Arcforms to showcase the 3D printing of hemp biomass in the environmentally friendly construction. This amazing all-natural building material is made only of hemp pulp, lime binder, and water. The carbon-neutral houses are designed for modern, energy-conscious, sustainable living and take just a few weeks to build. Besides being 10 times stronger than concrete, the hemp housing material is also fire, pest, and termite resistant and has significant noise-suppressing qualities. In the venture's latest housing developments, energy-efficient ventilation systems will be installed to ensure fresh airflow throughout the houses. In 2018, Mr. Richard Evans founded Mireko with a focus on mainstreaming the use of hemp to address the growing environmental crisis. According to Mr. Evans, we must consider the impact during the manufacturing of materials and assembly methods to construct the building, and hemp is renewable, sustainable, and clean. He also sees great potential in using the technology to build affordable social housing once Mireko scales up production. Next, we are happy to share the news that in Latin America, a community of 50 farmers and weavers will soon be living in a 3D printed village. Mr. Yves Behar, founder of the award-winning design firm Fuse Project, claims increased density in cities, rising housing costs, and homelessness present challenges that architects and urban planners must respond to. Mr. Behar proceeds with a brilliant plan to tackle the issues of those in need of homes. Fuse Project has combined forces with the home building technology company Icon and the non-profit group New Story in a joint venture to build 3D printed houses for an impoverished Latin American farming community. The venture's collective effort to provide the most cost-effective and sustainable solution to social housing merges design, technology, and community organization. The project is spearheaded by New Story, which is dedicated to tackling homelessness with new home-building technologies. Icon's large-scale portable 3D printer, the Vulcan 2, is designed to produce nearly zero waste and to function under difficult circumstances such as limited water and power. The three companies revealed their plans to use the latest technology to form the world's first 3D printed community. The work is being done in close interaction with local residents to learn about their culture and surrounding environment. Besides ensuring the viability of the physical infrastructure, the team has also looked into local community needs and traditions. The 3D structural designs will be affordable, safe, functional, and scaled to meet the needs of families in the rural communities without compromising aesthetics. Each of the 3D printed homes will cover an area of 120 square meters, with the interiors measuring approximately 55 square meters. The homes are designed to survive in challenging environments, with slanted roofs that protect from heavy rain and reinforced walls that can withstand earthquakes. The design also incorporates a covered outdoor kitchen, a dining room, and a garden space. Natural ventilation is provided by a border of patterned concrete bricks. We'll now take a few minutes to go outdoors and appreciate Mother Nature's flowers and other wonders. Please stay tuned to Supreme Master Television. Welcome back, loving viewers, to our show. Solar panels and water tanks can be added to houses to completely eliminate monthly electricity and water bills. In the town of Massa Lombarda in the Emilia-Romagna region of Italy, an eco-friendly house was recently built using earth obtained from the surrounding area. The mud house has been dubbed Gaia due to the use of raw soil as the main binder of the constituent mixture. The construction of Gaia was done by Italian 3D printer manufacturer, World's Advanced Saving Project, WASP. The WASP was founded in 2012 by gifted electronic talent Massimo Moretti, inspired by his vision for a perfect approach for building low-cost houses using natural materials which are sourced at 0 kilometers. The 3D printer crane WASP was developed to print on an architectural scale with the use of raw resources found in its surrounding area to reduce transportation and material costs. The external casing, entirely 3D printed on site, has been designed with the aim of integrating natural ventilation systems and thermoacoustic insulation systems in a single approach. The use of natural, earth-based resources to build Gaia was made possible through collaboration with RiceHAUS, an organization that focuses on repurposing waste from rice cultivation. RiceHAUS supplied the vegetable fibers for the bioclimatic eco-house project. According to Tiziana Monterisi, CEO of RiceHAUS, Gaia was made exclusively with natural materials such as raw soil, shredded straw, husk, and wood, and is high-performing from an energy and environmental point of view. In October 2019, it was announced that work is advancing on a construction project spearheaded by WASP and Mario Cucinella Architects for a 3D printed habitat near Bologna, Italy. The new habitat model was named Tecla, after an imaginary city described by Italian author Italo Calvino in his 1972 novel The Invisible Cities. As a continuous urban evolution, Tecla has the potential to become the basis for brand new autonomous off-grid eco-cities. Kudos to all the innovative companies working to provide intelligent, eco-efficient, and affordable housing for those in need. And finally, here is some out-of-this-world news about yet another 3D house model. AI Space Factory, a New York, USA-based multi-planetary architectural and technology design firm, launched Terra, a high-tech futuristic eco-habitat designed for off-grid living on Earth. The original version of the 3D printed prototype, a Mars habitat called Marsha, was designed by AI Space Factory for the NASA Centennial Competition 3D Printed Habitat Challenge. After NASA named Marsha the winner, AI Space Factory decided to construct its first Earth habitat, Terra. The same design and production concepts developed for sustainable life on Mars were used for the Terra architecture. The only difference between the two habitats is that Marsha was built using only fiber produced from basalt, a type of rock abundant on Mars, while Terra uses materials such as fiberglass derived from silicates found on Earth. Most of the materials used to build Terra are biodegradable and recyclable. The two-story Terra cabin will be nestled in the woods with views of the Hudson River. Inside Terra, the ground floor will be the living area equipped with a bathroom and shower, a food preparation counter, and a living room with a seating area that folds out to become a terrace. The second floor, which will be accessible by a wooden staircase, will be the sleeping loft that can double as an eating and gathering area. Diamond-shaped windows provide views of the surrounding rural landscape, while an outdoor terrace overlooks the riverbank. CEO and Chief Architect of AI Space Factory, David Malott, shared the following views on sustainable building materials. Terra will challenge everything we know about architecture and construction. It could transform the way we build on Earth. The first, Terra accepts limited pre-bookings on the US crowdfunding website Indiegogo, and starting March 2020 will be available for habitation for 1 year before it's recycled and reprinted elsewhere. Every stay in Terra contributes to the Habitat's scientific mission, emphasizing the need for renewable technologies to save our planet while researching what's needed to enable life to exist on a new one. Many thanks to the inventors and architects who are advancing the sustainable lifestyle and presenting eco-friendly housing technologies. May your loving kindness benefit other beings, including our precious animal friends. Delightful viewers, thank you for being with us for the concluding episode of our series, Intelligent and Sustainable Housing Solutions. We look forward to seeing the remarkable eco-housing technologies featured in our series become the norm in the not-too-distant future. Coming up next is Pira Ram, vegetarian, compassionate earth hero of Rajasthan, right after Nerdworthy News. May heaven bless you in all areas of your lives.
Our programs offer many languages. Please visit suprememastertv.com/schedule and suprememastertv.com/GAT.